So when we need to determine the number of significant figures in a number that we're seeing, there are actually 4 cases we can work with. Now the first case is one where the number is less than 0.1. So if we have a number like 0.0123 or 0.001230 or 0.00012300. When we want to figure out the number of significant figures, we have to eliminate basically everything that's what's considered a placeholder. So you see how we have this 0.0 here? Well, the 0 here is just a placeholder. Well, all it's telling us is that the number starts here. Now, if we were, say, working in meters versus centimeters, we could shift where this decimal point is. And that's the reason why we ignore leading zeros, is that we can get rid of them or we can add them depending on what conversion factors we use. So when it comes to case 1, when your number is less than 0.1, what you need to do is erase what are called the leading zeros, so get rid of them. So everything to the right of the decimal point that's a 0, scratch it, it doesn't matter. The numbers that remain are significant regardless of what their value is. So the first non-zero number is your first significant number. So in this case we have 1, 2, 3. And since we have these 3 numbers, we say this has 3 significant figures. To our next number, 0.001230. 1 is our first non-zero number. We've got 2, 3, and 0. Once we get rid of the leading zeros, everything that remains, regardless of whether or not it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0, is still a significant number. So in this we have 4 significant figures. For this number, 1, 2, 3, 0, 0, again, we're going to count these trailing zeros because we're working with a number less than 0.1. The leading zeros, when you're working with numbers less than 0.1, leading zeros get ignored, the trailing zeros get considered. So in this case, we have 5 significant figures. Case 2. We have a number with a decimal point, and we have numbers above and below the decimal point. So this would be something like 1.23, 12.30, 123.000. So these are numbers that contain a decimal point, and we don't have any leading zeros. In this case, every number is significant, so we just count the numbers that are there. So we have 1, 2, 3. This is 3 significant figures. 1, 2, 3, and 0 are going to give us 4 significant figures. 1, 2, 3, 0, 0, 0. These are 6 significant figures. Again, if you have a decimal point and you don't have leading zeros like you do here, you're going to count every number as significant. Now let's say we go to case 3. Case 3 is a number with what's called trailing zeros. So let's say we have the number 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 0, 0, 0. The big tip off here that every number, big tip off we have with this case is that we don't see a decimal point. So the number is greater than 1 and we can have trailing zeros. Now, in case 1, we got rid of leading zeros because we can get rid of them just by using conversion factors. Like if we go from meters to millimeters, we can shift everything over. The same thing is going to be true here. Unless you see a decimal point or a bar, and we'll get to when those examples happen quickly, everything that's a 0 to the right gets ignored. So in this case, we don't have any zeros, so we've got 1, 2, 3, 3 significant figures. For 1, 2, 3, 0, we've got 1, 2, 3, but we have this trailing 0. We could get rid of this if we switched from like meters to kilometers. So we're just going to get rid of the trailing 0. This is going to leave us with 3 significant figures. Again, down here, we're going to get rid of our trailing zeros. And this leaves us with 1, 2, 3 significant figures. Now, all these numbers are just shifted by a 0. There isn't any more precision associated with this number, and because of that, we can get rid of the trailing zeros and ignore them. They're just effectively a placeholder. They're telling us what power of 10 we're working with. Now, there are 2 exceptions to this. So let's get rid of the last 2 examples. Let's say we have 1, 2, 3, 0, 0, 0. Now, there are times when the last number is 0. There's no way to get around that. So we can take a measurement and we end up with 1,000. But we know the 1's position precisely. What we can do is if we put a decimal point right here to the far right, this is going to tell us that this 1 position here is significant. If we added a 0 here, we'd be overstating our precision. So it's going to behave the exact same way it did for case 2. If you see a decimal point, you count everything, assuming you don't have any leading zeros. So we've got 1, 2, 1, 2, 3, 4, 5, 6 significant figures. Now let's say we take this measurement, and it's not the 1 position we know precisely, but we know the tens position. Another thing we'll see is a bar over the number. So if you have 1, 2, 3, 0, 0, bar 0, this bar is telling you that everything to the right is a trailing 0. You can ignore it, but this 0 is significant. It's just that the significant number, the last significant number, happened to be 0. We don't want to be lumped in there with the trailing zeros. So everything to the right of that bar, you're going to cross out, and everything that remains is a significant number. So we've got 1, 2, 3, 4, 5 significant figures. Last case, scientific notation. Now when it comes to scientific notation, your number is going to take the form 1.23 times 10 to the third, 1.23 times 10 to the negative 4, 1.2300 times 10 to the 9. Basically, you have some number with a decimal point raised to some power of 10. The nice thing about scientific notation is that it's going to behave just like case 2. Every number here is significant. The 10 is just here to shift position. So like I said, we've got trailing zeros and leading zeros. We can get rid of them. We did a conversion factor that shifted power to 10. Basically, what this is doing is getting rid of that guesswork. So here we've got 1, 2, 3 significant figures, 2, 3 significant figures, 1, 2, 3, 4, 5 significant figures. So these are going to behave just like case 2. Every number you see in front of this power of 10 is going to be a significant number. You just need to count them.